¿Qué onda? ¿Me escuchan? Ah, pero sí. Saludos, saludos. Improvisado, ¿no? La conferencia, estarás preguntando. Es una conferencia sobre Machine Learning. Daría la atención a ver la sesión. No, también vamos a estar jugando Minecraft un poco. Pero estoy estrenando el nuevo micrófono también. Este stream. Creo que no lo había utilizado antes. Demetrius.
Hello, everyone. What is happening? Welcome to Apply.
¿Qué onda,
This
Tricatch?
is pretty exciting. I think we have got an incredible day planned ahead of us. It's nice to see some familiar faces in here. And looks like this event is shaping up to be one of the best conferences of the season, potentially of the year. We're glad to have everyone with us, but before we start, Tecton has asked me to read this disclaimer, so I'm just going to go ahead and do that and get it
Vamos
out
a
of the
ver
way
si
real fast.
tengo permitido reproducir
Tecton is
esto.
pleased to have you joining the event. Before we start, we would like to take a moment and stress that the statements, thoughts, and opinions of Dimitrios Brinkman in no way reflect the opinions of Tecton AI or the partners. In no way does Tecton assume any legal responsibility for the actions of Dimitrios Brinkman. All right, now that that is out of the way, thanks for the vote of confidence there, guys. I am Dimitrios Brinkman, in case you were wondering, and I want to say a few things before this whole event kicks off. We have a Slack channel. I want to remind everyone that the Slack channel is where all the banter and all of the great insights are going to be shared. So I know it's tempting to put something in the chat here on Zoom if you're with us live in Zoom, but go ahead and check out the link that should be in the Zoom chat right now and join us in Slack if you're not in it already.
Por cierto, esta también está siendo transmitido en YouTube. Por si lo quieren ver ustedes por su cuenta.
Use Twitter and any kind of social like LinkedIn to let the world know about this conference. If you're having a great time here, we encourage you to let people know, and hopefully it will spread and they will be getting all the insights that you're learning here. You can post with the hashtag, I think you saw it if you were here earlier. You can post with the hashtag ApplyConf.
No sé qué tan legal sea esto.
Or machine learning, whatever you feel is right. Or don't post anything.
Hola, Marty McFly.
Oh, let's thank Tecton for this incredible event. We also
Estamos viendo, es una conferencia que se llama Apply.
who are here with us today
de Machine Learning y Data Engineering. Esta de acá. Ustedes van a applyconf.com, ahí pueden acceder a la conferencia directamente.
We've got slides. You'll see those slides coming up. And the last thing that I will mention is, just like in any event, we would appreciate it if you be cool and you follow the code of conduct. As with in-person events, you want to be nice and have fun. So I think that is about all the announcements that I have. Now we are going to start.
¿Les gusta el Machine Learning? Que va, es random. Es una conferencia de Machine Learning y Data Science. Y Data Engineering.
Ops community, and that is a community that we've started for MLOps specifically. And so if you would like to join.
Sí, claro. Aquí voy a estar comentándola. Y bueno, ahorita lo que está haciendo el sujeto es invitándonos a conversar entre nosotros. Ahí está, tiene un canal de Slack y hay un canal de YouTube y demás. Pero sí, hay pláticas, va a haber pláticas muy entretenidas, creo yo. Por cierto, igual la conferencia es gratis y los videos van a estar arriba. Los van a subir ya después de la conferencia, o un par de semanas después.
That the first talk is going to be
La primera plática va a ser de esas personas. Mike es el fundador y el CEO, uno de los cofundadores y CEO de Tecton. Tecton es la compañía que está patrocinando la conferencia. Y Fist, no sé qué sea Fist. Van a poner un video o algo así.
Mike and Willem are going to be available, and hopefully every speaker is available in the chat. So jump in the chat and you'll be able to talk with all of the speakers after.
Sigue hablando de cosas del chat y demás.
And you can ask them questions, you can get more insights from them. Should be a good time. Now, the other thing that I will mention.
Entonces me dicen si dejamos el inglés o ¿dónde checamos los links? Déjenme los pongo en el chat.
So I will mention, my job is to make this hopefully be a little bit more fun in between all of the talks, and we can take our minds off of the deep knowledge learning that we have. So there is.
A ver, déjenme les paso el enlace a la conferencia. Están haciendo un concurso de selfies. Yo no le voy a entrar, pero quieren entrar. Ese es el enlace a la conferencia. Lo pongo también en Twitch. No sé si alguien esté viendo desde Twitch, pero si están por allá, lo ponemos. El que está anda diciendo algo de un concurso de selfies de nuevo. Yo no voy a entrar al concurso. O tal vez deba entrar con mi playera de Campos. Tal vez deba entrar.
with the good selfies. So it's an easy way to jump
De
on
este otro lado tengo el centro de control,
bandwagon and get some free stuff.
donde estoy
All
viendo
right,
todo y controlando todo.
there we go. Now let me jump back into introducing Mike and Willem. And so before I got horribly derailed, let's talk about Mike and Willem. If you missed, I said it. Mike, co-founder of Tecton. Willem, co-creator of Feast.
Ah,
Willem, before he was working at Tecton, he was the data science platform lead at Gojek. And Mike,
sigue hablando de los presentadores.
or creating
Son
Tecton, he was working at Uber.
el CEO, el CTO, algo así, cofundadores de las empresas que están organizando la conferencia.
So it's going to be a good one. Now,
A ver cuál es la primera sesión.
but not least, as I mentioned, if you want to talk with Mike and Willem after this talk, you can do so in Slack. And that is about it. I think we are queuing it up. Mike and Willem,
Pero vamos a
onto
ver.
the stage if you can.
Hello and welcome to the Apply conference. I'm Mike. I'm the CEO of Tecton, and we're hosting Apply.
Mike, el CEO de Tecton.
It's the first time running Apply, and so if it goes well, we'll do it again.
Es la primera vez que es la conferencia.
A year from now, what is this conference about? It's about all the data engineering challenges that we have when putting
Sobre data engineering.
when doing applied
Poner machine learning en producción.
this is a really huge space. There's a variety of different problems, and the talks in this conference will be deep dives into different subproblems. The idea of the conference is to just bring people together and talk about some of the solutions, the things that they've built that have worked or that haven't worked.
Hola, Martín Bajo.
Hopefully,
Estamos viendo una conferencia de
you'll get some
machine learning
you can bring back to
y
your own teams.
data engineering.
Okay, we're going to talk about productionizing machine learning with feature
Bueno,
stores.
poniendo en producción machine learning con algo que se llama feature stores.
Creator of Feast, an open source feature store, and a tech lead at Tecton. So where do feature stores come from? Well, we worked on and built a machine learning platform at Uber called Michelangelo. That platform, supported all the machine learning that runs in production at Uber, thousands of real-time models like fraud detection systems, ETAs, stuff like that. And this platform is really three parts. There's a feature store layer, there's a model management layer, and then there's this observability model monitoring layer. And the feature store was really like a central hub for managing the data flows in the ML application, and allowed teams to iterate really quickly on features, to transform data from raw data into ML features and deploy them to production quickly. And this feature store kind of became the foundation for all the ML systems at Uber. Today, feature stores are a whole category. We left Uber to create Tecton. Tecton is a fully managed enterprise feature store. Feast is another feature store option.
Los creadores de estas empresas dejaron Uber para crear estas herramientas, estas compañías.
But overall, today we're going to talk about why it's so hard to productionize machine learning and how a feature store helps with a lot of these data engineering challenges. We're also going to talk about what's within a feature store, how do they work, and how are they relevant for core ML ops workflows. And then at the end, we have an announcement of a new release of Feast, and we're going to talk about the key.
¿Algún libro para empezar? El de Hands-on Scikit-learn and Hands-on Machine Learning with Scikit-learn and TensorFlow.
Modern data stacks are really built around these cloud-native data platforms. So this is your cloud data warehouse or a next-generation data lake, and they have really risen in popularity dramatically over the past few years. We love our data warehouses.
Bueno, esta conferencia de nuevo se trata de Machine Learning y Data Engineering, y esta persona está hablando de una cosa que se llama Feature Stores, que es como una base de datos de información que ya fue transformada por científicos de datos o algo así, y entonces en lugar de que los científicos de datos tengan que transformar la información extraída de una base de datos, por ejemplo de SQL y demás, simplemente la extraen de este Feature Store y ya pueden hacer Machine Learning directamente con esta herramienta.
What about machine learning? What have they done for ML? Not the exact same thing. So let's just look at what is required to build a machine learning system. So with ML, of course, we have to train our model. And so we can do that with a data science environment, say a Jupyter notebook and an ML framework. But it's not just that. We also have to deploy our model. And we deploy our model into a different environment. Our models run in production. Imagine this is like a real-time
Buenas, Diego Barra Molina.
access to training environment for model
Hola, Dayana. Estamos viendo una conferencia de Machine Learning y Data Engineering.
analytics teams have been refining and cleaning and making much higher value. We've put a lot of energy and investment into that already. However, this is not always super easy, right? There's a variety of reasons for this, and we'll just jump into a couple of different ideas here. One is just like there's the data that my model can use for predictions and in production is not always available in my data warehouse, right? It could be for security reasons. Production data doesn't go there. Another reason is just often the data that does land in the warehouse has been transformed. It's been cleaned in some way. For example, it's been sanitized, it's been typecasted, downsampled, ordered, and it's not necessarily representative of what my model would see in production. So it introduces some data consistency issues. And let's also think about like, what about the data that is in production that my model would get for predictions? Well, maybe we can use the same kind of data warehouse for that. And this also isn't really easy. It's actually even harder. You know, these systems don't have real-time serving. They don't have good streaming support. They can't do real-time transforms or like transactional
Ah,
and
así de rápido, cuando trabajas desde remoto desde México para el Reino Unido, ¿a quién le pago impuestos? A Reino Unido.
production teams run your production fraud model, and they don't really trust taking a dependency for their production fraud model on
Ahorita
a data system like a warehouse
lo que
with
este
minimal
señor está
capability,
diciendo es que
and so they don't want to make
directamente los algoritmos de Machine Learning no consumen la información como llega del exterior. Tiene que existir un proceso de transformación antes de que esta información se utilice para Machine Learning.
managing the complexity of ensuring that data is consistent across environments. For machine learning teams to be fast and effective, they can't be dealing with this complexity in every single iteration loop. They need tools and workflows to be able to iterate quickly on features and have them be easily available for training and production inference. Just remember that the correctness of these ML systems, them functioning at all, on getting the same data inputs across these environments.
Por ejemplo, lo que está diciendo ahorita es que si tienes diversos equipos de Machine Learning, idealmente querrías que todos estuvieran utilizando como que la misma información.
In your team. One thing that's quite common for teams to do is to rebuild the offline pipelines online. So they'll
Y que, por ejemplo, si tienes diversos equipos, puede que ellos estén realizando las mismas transformaciones, las mismas herramientas, cada equipo separadamente.
teams have to be really heavily involved in every single iteration, and it's very error prone. The data across these systems is now going through two different transformation pipelines, and so there's no guarantees of data consistency, and it always leads to
Y bueno, ya saben, ¿no? Que una de las reglas en la programación es no te repitas a ti mismo, es decir, no trates de reinventar la rueda.
it's a tricky situation. So how can we make productionizing machine learning as fast and easy as building something like a dashboard on a warehouse? Feature stores are built exactly for this, right? They're the hub for a data flow in a machine learning application. And they're focused on solving these data complexities for putting ML applications into production. So they do a bunch of things like ensuring transformations are consistently applied across environments, organizing data for use in ML, and making feature data accessible for online inference and offline training, and monitoring this data and keeping it validated. The most important thing though is offering a very simple workflow for teams to quickly iterate between development and production with their data. So the feature store does this not by duplicating your data stack, but by integrating with it and extending it to provide data workflows and interfaces for ML developers.
No sé si se dieron cuenta, pero de este lado tenían como que la base de datos y todas las entradas al modelo o no, al machine learning. Y tienen su data platform aquí en medio. Y en medio está el feature store, que es de lo que va a hablar ahorita el mono.
Right? So of course the feature store, we need to serve features in production. So we have, your production application, it has to request features. The feature store has to deliver features to a model to make a prediction. It also needs to interact with your development environment. So, your notebook or your data science environment, you need to be able to talk to the feature and ask for a training data set, right? Ask for different features so you can build your models. And the feature store, of course, is connected to your upstream data. Stream sources, batch sources. This can also be operational sources like operational databases, even third-party data sources, kind of common like vendor APIs. And so what's going on within the feature store? Well, there's a couple of main capabilities. First is serving. So it's all about delivering feature data to, to your model. So ML models can require a consistent view of feature data across training and serving. When we're creating training data, we need to actually train on historical examples. And so it's actually pretty common to
Hagan, ahorita lo que está diciendo es que una de las características de estos feature stores tienen que tener la posibilidad de darles, más bien de que ustedes puedan extraer vectores. Esos vectores representan la información que obtuvimos previamente. De hecho, aquí es en donde entra, no sé si han estado presentes en el curso de Data Fundamentals que estoy dando los sábados. Y bueno, justamente la vez pasada, la semana pasada, el sábado pasado hablamos sobre por qué es importante vectorizar la información. En las feature stores es donde nosotros podemos almacenar estos vectores de información una vez que ya los procesamos.
contains the freshest values of each feature and it powers that real-time serving to your model for inference. And the offline storage layer is what contains all the historical values of different features, so such that you can go back in time for training, for assembling training data sets that represent historical examples. And the feature stores organize the data in these storage layers in a really nice way to make features really easy to join together. So they're organized by like a primary key, like an entity. We call them an entity ID, user ID for features that are user features, and they all are tagged with a timestamp, so we can go through different historical values. And then feature stores actually run the feature engineering transformations to convert raw data into feature data. This happens by orchestrating transformation jobs on your existing infrastructure. So think about like running a SQL query on your warehouse or running a job on your Spark cluster. Many of these feature pipelines are expensive and they need to actually, to compute a feature, you pre-compute it. You can
Y bueno, lo que ahorita menciona es que extraer estos vectores de nuestra información es costoso, obviamente, porque tenemos que realizar operaciones, no sé, sobre el texto, tal vez tokenizar el texto, tal vez aplicarle, convertirlo a TF-IDF o algo así, o normalizar nuestros datasets y demás. Es decir, la información que obtenemos del mundo real, de nuevo, tiene que sufrir transformaciones antes de meterlos a nuestros algoritmos mágicos de Machine Learning. Y bueno, lo que hacen estas feature stores es almacenar esos vectores una vez que nosotros ya los calculamos, para no tener que volverlos a recalcular más adelante y que diversos equipos puedan acceder a esa información una vez ya calculada.
is extremely important to anybody running a production ML application. So, the feature store is the interface between your models and your data, and they organize all the data that is important for model operation, but also for model debugging and auditing. So feature stores do not only like data quality monitoring, but they're also pluggable with external monitoring or data observability systems. So it's really about organizing these data sets, making all of the training data, the serving data accessible
Eso,
to any other system that wants to generate metrics and validate data quality. Feature stores can be extended not.
eso está interesante, porque, bueno, también ofrece capacidad de observar cómo se comporta tu dataset para que puedas detectar si la calidad de tu dataset o la información que está llegando se está degradando. Esa información se almacena en una base de datos no SQL. Definitivamente es no SQL, solamente que no sé cómo esté organizado internamente. Porque lo más... A ver. Ok, no. No, está hablando de otras cosas ahí.
It contains all of the definitions and the metadata that can be used.
Pero no, seguramente es algo de no SQL, porque no es SQL. Pero no sé cómo esté organizado internamente.
Our user registry to figure out when to ingest data, when transformation should happen, what data to store and how to organize it. But all of this together allows the feature store to become almost this data catalog of production ready signals. So you suddenly have this library of signals that have already been found useful for other people and they're ready to go in production right now. What's great about this is that it removes a cold start problem for data science projects, for testing new data science ideas. Now you can essentially just like new idea, create a model with these set of previously existing features that others have already found useful and put it into in a full-scale production experiment in minutes. And so this dramatically speeds up the data science experimentation cycle and really solves this cold start problem. So look.
Bueno, y sí, lo que estaba diciendo ahorita tiene mucho sentido, que si ya tienes todas las features calculadas en un store, ya tienes mucha información ya preprocesada, es más fácil realizar nuevos experimentos, porque ya no tienes que perder o gastar tiempo en extraer información, transformarla y demás. Ya está toda la información precalculada ahí en el Feature Store. Bueno, ahorita está hablando de qué es lo que te ofrecen.
We're not talking about adopting a whole duplicate data stack. Feature stores aren't introducing a new type of database, a custom re-implemented key value store. They run in your cloud environment. They reuse your existing data stack. They extend your existing infrastructure. So they reuse your Spark cluster, they reuse your warehouse, and it will even reuse your storage layer. So its features will be stored in your warehouse or in your data lake, so you can access them for other use cases beyond just feature retrieval for machine learning as well. Getting benefit from a feature store is not an all or nothing proposition. Feature stores are incrementally adoptable. So what does this mean? Well, you probably already have some existing feature pipelines, right? So here we're looking at two existing pipelines, one that powers your training, one that computes some features for your serving environment. And to get started with
¿Alguno de ustedes ha trabajado con Machine Learning o algo así?
integration, you really are just trying to add some new signals to your model. And the feature store is all about that. So it's really an incrementally adoptable system. You don't need to rewrite your existing pipelines to begin using the feature stores. They're built to work alongside your existing infrastructure that you are already happy with, and it's already built and working. So it's common for teams to start using feature stores to just get the new features they've always wanted in production without dealing with migrating a bunch of old stuff that happens to be already working. And another thing that's quite common is after teams get to this point, they actually really like the feature store interface. So they want to integrate their existing pipelines with the feature store. So they get to take advantage of that unified feature retrieval interface that the feature store provides. And so they end up connecting their existing pipelines directly to the feature store
Okay.
and having a single interface that they connect to retrieve their features across all of their models. So we just talked about a lot of different data engineering problems that
Hay
need to
buen
be solved
aporte
when
para
putting
Machine
machine
Learning.
learning into production.
Machine Learning es bastante divertido, aunque a veces puede ser frustrante, pero si es algo que les interese, denle. Pero es divertidísimo. Y bueno, ya saben, es lo de hoy, ¿no? Bueno, ahorita está hablando de que existe esta Feature Store, esta base de datos que se llama Feast. Y Tecton es la empresa que está trabajando con Feast.
Hello everybody, and let me introduce Feast 0.10 to you all. So the feature store principles and capabilities that Mike just presented form part of a broader vision we have for feature stores. Feast 0.10 is the first step towards that vision, but it's specifically focused on serving. Our goal with Feast 0.10 was to make the simplest and fastest feature store for ML teams to serve their analytic data in production. Feast 0.10 provides training dataset building with point-in-time correctness, helping you avoid feature leakage, online serving of your data at low latency, and provides consistency across these two environments. This first release is GCP focused, meaning you get BigQuery as your offline store, Firestore as the online store. The key problem we're trying to solve with Feast 0.10 is, how can we make it easy for teams to deal with the complexity of data consistency across environments? So let me walk you through some of the key changes in Feast 0.10. Firstly, at zero config. With Feast 0.10, we allow you to deploy a batteries included feature store without any custom configuration, meaning you can just get started and
No sé por qué optaron por usar Google Cloud Platform de entrada.
meaning you can test your end-to-end development workflows completely locally from either your IDE or a notebook. Third, there's no infra involved if you're just getting started. That means no Kubernetes, no serving APIs, no Spark.
No Kubernetes.
If you want to use Kubernetes, you can use the open source components that we provide. That's always the option if you want flexibility, but it's not required if you're getting started. And then finally, Feast 0.10 is extensible. It ships with a provider model that allows teams to easily extend Feast for deployment into their own custom stacks. So let's talk about the demo that I'm going to show you in a second.
Viene un demo.
Then we're going to train a model using features from BigQuery, and we're going to use Feast as the interface to BigQuery. Then we're going to do a testing of the model with a local online store using SQLite. And then we're going to test the model with the production feature store. So we're going to deploy Feast to cloud, to GCP cloud, and we're going to use Firestore for online serving.
Son un montón de tecnologías todas juntas, ¿no?
And out of these drivers, we need to pick.
El código se ve horrible de todos modos en mi pantalla. A ver, déjenme ver si lo podemos componer. No, se ve horrible. No sé si es mi transmisión o simplemente su zoom.
Respond in low latency. We know that we have a lot of data in BigQuery for drivers, so let's have a quick look at that. I'm going to run a quick BigQuery query, and we should get results back in a sec. Right, so now we can see that we have a bunch of data in the offline store in BigQuery on drivers, so conversion rate, acceptance rate, and average daily trips. We can use this to train a model. So we know that we have that available. So let's start a Feast repository in order for us to set up our feature store as the first step.
Bueno, aquí no tiene tanto sentido porque no podemos ver código y no podemos ver los resultados, pero aparentemente todo se hace desde, sí, directamente desde la consola. La mayoría de estas herramientas almacenan toda la información en algún bucket, por ejemplo en S3, en un S3 bucket o en GCP, en alguna de las cubetas de Google Cloud. Y supongo que Azure tendrá algo similar. No sé si está utilizando Python para todo, creo. Digo creo porque de nuevo no se alcanza a apreciar bastante ahí. Buen día, Jaime. Saludos. Estamos viendo código. Parece que alguien lo embarró con mermelada. Está haciendo un demo de una cosa que se llama Feature Store, que es una base de datos para vectores. ¿Han escuchado hablar de una tecnología que se llama Snowflake, por ejemplo? Me imagino que esto es algo muy parecido a Snowflake, pero optimizado para almacenar vectores o puntos numéricos.
to the registry or to a local repo. And so that's what we've done here. Then what you do is you just call a single method in order to build a training data set, get historical features. Feast is going to intelligently build a training data set, and it's going to query BigQuery and find those driver features and join them to the data frame that you provide. In this case, you're providing an orders data frame that has a rows that contain a column called trip completed. And that just says, did this driver complete or did they not complete a historical trip? And so Feast is going to intelligently join those tables together in a point-in-time correct way. And then we're going to train a model and save that model. So let's just quickly run the script. Right. And so
bueno, y para responder a Marty McFly, no creo que te provoque ningún inconveniente. Lo que te recomiendo es que no trates de brincar luego a lo del deep learning o algo así. Y lo más probable es que cuando comiences, hay muchas herramientas online. Por ejemplo, está Google Colab, está Kaggle, hay un montón de herramientas en las cuales puedes correr tus notebooks en la nube y en realidad creo que ahorita no importa tanto la computadora que tengas, al menos cuando estás iniciando. Así que si estás más cómodo utilizando una Mac, adelante. Pero te digo, no necesitas algo súper poderoso de todos modos. Y la Mac la nueva Mac en realidad no sé qué tan bien se comporte.
This class, we're going to load a model into memory, and then we're also going to create a feature store object, just like we did for training. Let me show you what prediction looks like. So for prediction, remember, we're going to get a list of driver IDs, right? So we get that list of driver IDs. Step one, we're going to read features from Feast, the online features. And so we take the driver IDs, and we take the same list of features we used for training, and then we just query that from Feast. And then we get back, the data frame from Feast. And this, in this third step, we're
No hay problema, Marty. Ahí nos dices qué terminas comprándote.
and you can develop and then test this, out before you actually go to prod. And so you've got your data, you make a prediction, you choose the best driver, and you return the best driver ID. So let's quickly try that.
Esta cosa se ve bastante interesante. Nada más que obviamente tiene sus pros y sus contras. Porque como ya tienes todos los features precalculados, puedes limitar la cantidad de innovación que tu equipo realice. Porque como ya tienen todo ahí, probablemente no quieran explorar o no tengan el incentivo para explorar nuevas transformaciones o buscar otras alternativas a lo que ya existe en el Feature Store. Entonces, existe como que también un pequeño riesgo ahí a utilizar estas Feature Store. Son muy prácticas al parecer, pero definitivamente no son solo cosas buenas.
Just take a few seconds. Yep, done. Okay, so let's rerun our prediction routine. The cool thing now is we don't need to change our online prediction routine. We can just rerun it because the online store has changed, but everything has been commoditized about the prediction script. And then we have 1001. That's the exact same result we got locally. And now we have a production store. So just as a recap, we set up a feature store, we train a model using Feast and querying data from BigQuery in a point-in-time correct way, and we use the local SQLite to test the online store capabilities quickly, and then we shipped Feast into production, and now you can just ship your model into production, and you have a complete production setup with almost no infrastructure that you have to maintain. It's just a bucket and a serverless Firestore.
Volviendo a algo que habías preguntado por ahí, Beto, al parecer están utilizando, para desarrollo local, se utiliza una base de datos en SQLite, así que tendré que investigar un poco más, al menos cómo es que funciona Feast, que es la herramienta que estamos viendo ahorita, para ver si utilizan SQLite, si utilizan SQL internamente o si se utiliza alguna otra herramienta.
Working towards a unified specification for feature definitions. So what does that mean? It means that over time, Tecton will be releasing more and more of its internal technologies into the Feast project, and we'll have the possibility of being able to seamlessly move from Feast into Tecton as a managed offering. So if you want to try out Feast 0.10, check out our quiz.
No, está bien loco porque el Tecton es una empresa privada y al parecer está vaciando casi todas sus características en el proyecto open source. Bastante interesante. Y bueno, es que así es como funcionan muchas herramientas. Participan en proyectos open source y ellos ofrecen una versión con soporte. Más o menos lo que hace Red Hat con Linux, o lo que hace Elastic con Elasticsearch. Un modelo de negocio bastante interesante.
So bear with us. And we've got another session for you. Before we jump into the other session, there's some questions that are coming up in Slack about where to ask the questions for this last session and all the sessions. That will be happening in the channel called Applied Conference. So jump into that Slack and go to the channel Applied Conference. Next up, we've got Wes McKinney. I've been really...
Ahí viene otra plática según.
Yep, that Wes McKinney. All right, so Wes,
Es del desarrollo de pandas, creo.
an enterprise software company creating Arrow-powered computing technology for data science. He created the Python Pandas project and is a co-creator of Apache Arrow. Wes will discuss the coming architectural shift in data analytics systems enabled by the widespread adoption of Apache Arrow. He'll also advise how to plan for a future built increasingly on interoperable open standards. Wes, it is a pleasure to have you here with us. And
ese es el creador de pandas. Y va a hablar de algo que no conocía. Apache Arrow, supuestamente.
All right, thanks for joining me here today, or watching the video of this stream on recording. This is a pretty high level talk, so we're not going to be looking at a ton of code here. It's more of a higher level discussion of some of the trends that are happening in the world of data analytics and important changes in the infrastructure that are affecting all of our programming languages, all of our computational engines, our data analytics systems, and how we can begin to think about them and to work better together to enable this improvement of our computing infrastructure to happen more quickly. So I was just introduced. Most of you know me from my work on the Python Pandas project. I haven't been doing as much Pandas development for the last 8 years or so. So Pandas, in fact, is a 13-year-old project as of this month. And I was very active with it the first 5 years of its life, building the first versions of the project, beginning to build a developer community around it, writing my book Python for Data Analysis.
También les recomiendo ese libro de Python for Data Analysis. Bastante bueno.
In the project, people like you may know, like Jeff Reback, Joris van den Bosch, Tom Augsburger, and others who have carried on development up through the present. So when you're using Pandas and you're benefiting from its stability, its functionality, its speed, remember that there are many other people that are involved with making that project as good as it is today and as reliable as it is. So be sure to thank them and remember that it's been going on for over a decade, and a lot of the work has been carried on by the other volunteers in the project. So this talk is going to be specifically about different aspects of what I call computing silos that have developed in different parts of our infrastructure. And the three different kinds of computing silos that I want to focus on are data silos. So data itself, how data is stored, how data is accessed, how data flows around our systems. And then we come to computing engines, so systems that access data, compute queries on it, perform ETL, feature engineering, machine learning, AI, where the rubber meets the road and the computing happens. And then there is the problem of programming languages and language interfaces. And of course, computing engines and data have to be used through some programming language. And so the programming interfaces that we use are, of course, very important to us because they're the only way that we can get access to these systems. And one of the reasons that Python has become such a popular language for data science, for data engineering, is because the Python language itself is very pleasant to program in. You can
Dice que Python es bastante fácil para programar y bastante fácil para expresar. ¿Están de acuerdo?
day job. It's a language that as Fernando Perez says, the creator of IPython and Jupyter, Python is a language that gets out of your way, and so that's one of the reasons why it's become so popular. But there are other.
Y bueno, también gracias a Jupyter y Pandas.
There's JVM languages like Scala and Java. There's Rust, and a lot of people are excited about Rust nowadays. And of course, there's languages like C and C++ that have been around seemingly forever. So we have a lot of programming languages, and it creates distinct ecosystem problems around them and how they're used within, particularly within enterprises where you can't. It's not that you don't only have one programming language. In reality, you have multiple programming languages. So some of the problems that we see that are what I call data silo problems. One of the biggest issues is that many workloads are plagued by serialization overhead. And serialization is the computing work that is spent converting data between different formats. And so that might be.
En resumen, sí. Python es eso.
Into memory.
Es increíble, ¿no? Como yo creo que la década pasada y anteriormente se estaba hablando de computing silos y resulta que ahora estamos creando computing silos otra vez.
Time simply converting data from one format to another. Another problem that we see is that depending on the tool that you're using, how the data is stored, where you're accessing it.
Bienvenido al stream, Alejandro.
Data access and delivering data to applications is completely all over the place. So some systems are really fast to access data. Some systems are really slow. You have many different implementations of reader interfaces to files. So you might be able to read one CSV file in one application pretty quickly, whereas in another application it's much slower because you're using a different library to read the CSV file. So ideally, we would like to have consistently good performance accessing and delivering data in all of the places where we need it. Another problem that we see a lot is this problem of data being held hostage by a system. And this is not.
¿Qué onda, Alejandro? Saludos.
Which was in a very vertically integrated fashion. So you buy an appliance, which is your database system. The people in your company insert data into that system, and then the analysts who are working on the data send queries to the database, which serves as the Oracle. And there, of course, it's no surprise that one of the first database companies was called Oracle. The database computes those queries and returns the answers. But if you have an application where you need to export large quantities of data from a vertically integrated system that is responsible for storage, computing, and query interface, it can be quite slow to get data out of those types of systems. And so even though you can technically get the data out of many data warehouse systems, the performance of importing and exporting large quantities of data can create a lot of pain for the users. Another issue we see is that of different systems operating on different data. And so in modern enterprises, we see a lot of different systems for handling streaming and real-time data, and so systems that capture and deal with real-time data, and then a data warehouse system which operates on data that's been ETL'd into a particular schema that's optimized for query processing. And so many organizations are operating and running their workloads on stale data that where they might have an ETL lag of 12 or 20 or 24 hours or even more in some cases. Some of the problems.
Es una locura cómo se hablaba antes de que teníamos que subir todo a la nube porque teníamos silos y de nuevo resulta que hemos estado haciendo silos hasta ahora.
That are available in Python now. There's different data frame libraries in R. Though there isn't a great deal of overlap in the code between those systems, and so the performance can be all over the place. And you see a lot of internal competition within programming language communities, trying to see who can implement the best algorithms to attract more users to use their tool. One symptom of the fragmentation in computing engines is that hardware frequently goes underutilized. So, for example, a lot of systems in Python were built were built in the old days where you had a single core machine or maybe a dual core machine, and so writing algorithms to be able to utilize modern CPUs with 8 physical cores or 16 physical cores was not part of the design requirements, and so so many of our pieces of software are not fully leveraging the hardware capabilities that we have today. Of course, there are new kinds of hardware that have been created, like GPUs, and now there's many different custom chips for analytics and data science workloads, AI workloads that are in development.
Bienvenido, José Molina.
Is optimized for these new kinds of hardware, not only the current generation of CPUs and taking advantage of the specialized hardware accelerations that are available in those chips, but also taking advantage of new kinds of hardware. It's been pretty slow in practice.
Mucha gente. Saludos, Ernesto.
Hands of data scientists in their everyday, in their everyday work. So, for example, right now I'm working on an M1. I'm giving this talk from an M1 MacBook Pro. So Apple just changed architectures in their CPUs from Intel to ARM, and so all of that software which has been built that's been optimized for Intel hardware optimizations can't be used on an ARM chip, and so an entirely different set of hardware optimizations utilizing SIMD instructions for ARM need to be developed in order to fully utilize these new processors.
Algunos problemas con la M1. Por ahí Marty McFly.
Computing engine can also create like a sort of lock-in using that, using that engine, especially where there is a coupling to a programming language that you must use. Like, if you're using Spark, you really should use Scala to get the best out of Spark. So even though you can use Python, you do pay a penalty when you use Python on top of Spark.
Toton, sorry, Toton ZX, saludos.
Languages is that a lot of the computational machinery which is used in the implementation of the libraries that we have, data frame libraries, data science libraries, that there isn't as much code sharing between programming languages as we would like to see. And so many of these projects are their own little islands of algorithms and IO code. And, so essentially, if you look at Pandas has its own CSV reader, it has its own implementation.
Ahorita está hablando de un proyecto que se llama Apache Arrow. A lo mejor hablar un poquito de la arquitectura del proyecto, pero no estoy seguro.
Very quickly, but a lot of other open source projects have done the same thing. They've built their own full stack solutions to all of these problems, and there hasn't really been a basis of code sharing and collaboration across projects within languages and between programming languages. Another issue we see is that the language interface to a computing engine, what I was saying before, one programming language running on top of a certain computing engine can perform differently from another. And so to use Spark as an example, the performance of using Spark for certain workloads can be variable depending on whether you're using Python, R, or Scala. And so ideally what we'd like to see is consistent performance across programming languages. So if we had our way and we could, take a magic wand and redo the whole computing stack to be, the way that we would,
Ahí está un poco de arquitectura, tal vez.
so you can choose the programming language that best suits the way that you want to work, and that you don't face these various penalties around data access or computing performance or feature support in your programming language. So if you want to build applications in Rust, you can do that just as well as you could in Python or in Java. Our computing engines, we would like the libraries and the computing infrastructure that we're building on to be more portable and more usable in more places. We'd like them to be able to take advantage of hardware acceleration, new innovations in CPUs and new kinds of hardware like GPUs and specialized computing chips. We'd like to see those improvements make their way into the majority of users' hands as soon as possible, rather than taking years for the software to be developed to take advantage of those platforms. And by sharing more systems code, the work, the optimizing the compute engines will benefit everyone. So not simply the users of one particular computing engine. And around the data itself, pretty simple. We want to be able to access data efficiently, productively, quickly, in all of the places that we need it. Of course, the real world is messy, and so creating utopias in
Una Mac. Ahorita yo estoy utilizando una Mac del diario por el trabajo. Antes era de Linux y no me gusta tanto el sistema operativo.
data analytics work.
Sistema operativo de Mac.
So to build better computing engines, we want to be able to take advantage of hardware improvements much more quickly. We'd like to have systems that can leverage hardware heterogeneity. So if you have a system that has GPUs on it, that you can leverage both the CPU and the GPU to run, to optimize for the hardware that you have to run your workloads as quickly as possible. We'd like to see more ecosystem-wide collaboration on algorithms, particularly on leveraging advanced features in hardware. So we see canonical high-performance implementations of the critical algorithms that we need that can be reused by everyone. And another point with computing engines that's often lost is the importance of having high-quality computing at the small scale, at the laptop scale or the workstation scale. So you've seen so much work happen on scalable computing at the 100 gigabyte or 1 terabyte and upscale up to the multi-petabyte scale. But there's been relatively little progress, or comparatively little progress, on efficient computing at the single node scale. And so
Eso es algo que me molesta mucho. Soy muy fanático de una cosa que se llama desarrollo local, que consiste en que cualquier desarrollador pueda trabajar desde su computadora sin necesidad de conectarse a internet. Y bueno, me parece que se está dejando un poco de lado en favor de mejor tecnología en la nube, que obviamente creo que tiene prioridad, pero no es una experiencia tan placentera, me parece, al menos desde mi punto de vista para desarrolladores.
Language that best suits us, to not have an impossible choice between a programming language that we prefer to program in, but where we pay a significant performance penalty to use that language. Often that overhead can be that can be the result of serialization overhead associated with data movement. The compute engines should create interfaces to make themselves usable from any programming language that can bind with their low level interfaces, so that you aren't forced to go through necessarily a higher level language in order to access that system. And on data, where frankly the most progress has been made in recent years, the adoption of open standards like Parquet and Orc for analytical data storage has improved the data silo problem significantly. There's still many problems around dealing with very large data sets, large scale metadata, and the creation and adoption of open standards that are community maintained for data storage and metadata is a big part of the solution here. Moving data around and accessing data, having standardized protocols for data access, for moving data between systems is critical for dealing with the data silo problem. And to the extent that we can reduce couplings between data storage, data access in a particular compute engine to make compute engines more pluggable, more interchangeable, to have that architectural requirement forces will force a better design decision.
Pero no es, el edge computing es el que se lleva a cabo en dispositivos móviles, ¿no? Bueno, en la última línea del contacto con el usuario, ¿no? Como por ejemplo en los celulares o en los relojes super inteligentes. Es el edge computing, ¿no?
Computing engines and programming languages. And so I'm going to tell you a little bit about how we're doing that and where we are in the process, because many of you have heard of Arrow. It's been around for more than 5 years now. So maybe you're wondering, when is this going to make its way into my life and make things better for me? But we really do, from the early days in the project, 2015, when we began putting the project together, we saw it as a critical and fundamental part of beginning to solve these data analytics silo problems around computing data and programming languages. So we started this project around 5 years ago as a collaboration between a collection of data science, big data, and database systems developers. And the purpose was to create these shared technologies that could be used as the basis of a better development platform for data analytic systems. So not only data access, serialization, and data movement, but also building better computing engines and having better cross-language support for building our next generation of ETL, feature engineering, data analytics, machine learning architectures. So we're thinking about the problem is, on the data side, that we would like to see more and more systems accessing data and moving data around in the Arrow tabular columnar data format. And that's the area where the most progress has been made. And I'll speak shortly about some of the systems where this work has been done, and it's in progress in many other systems around the ecosystem. So it's not enough to be accessing and moving data around an Arrow. We also need to compute natively on the Arrow data. So we specifically designed the Arrow data format to be efficient for.
No conocía tanto este proyecto Apache Arrow. Y sí, hay una cosa que se llama entrenamiento federado que también tiene que ver con ese cómputo en el límite o en el borde, cómputo en Edge. Y sí, bueno, tiene ventajas y desventajas. Por ahí luego podemos organizar una plática, Totón.
Programming languages, we can enable them to plug into systems that are written in other programming languages and achieve interoperability or provide a language interface, for example, in Python or in Rust or in Go that has almost no overhead by virtue of having a common data structure, a common data format on both sides of the language divide. So the project has been growing rapidly. We've made 20 major releases. We have over 600 contributors, 600 unique contributors. So we've created a vibrant community around the project. We have.
Bueno, ahorita ya nada más está presumiéndonos sus cuadritos en GitHub. Pero recuerden que es el creador de pandas, así que se le permite.
Contributors will continue to grow, up and to the right as time goes on. For the people listening here, I think the most exciting thing that we've seen and that's making the most impact on your day-to-day lives is the rise of Arrow as a standard format for bulk data access and data interchange And so we've seen many databases and data warehouse systems adopt.
¿Cuántos de esos logos conocen?
So when you're using BigQuery or Snowflake, you can format, and then Arrow data could be loaded into Pandas really efficiently. We use Arrow to accelerate user-defined code running in Apache Spark. And Spark SQL does not use Arrow internally, and so there still is some serialization overhead when using Python on Spark or R on Spark. But by using Arrow for the bulk data movement,
5 logos. Bien. Colaborar en Sí, qué bárbaro. Tiene una de esas medallitas de Ingenuity. Bien por ustedes.
the interface between Arrow and Parquet files or ORC files is high quality, so that we can encourage more, that kind of in-memory interface where Arrow, we want Arrow to be the dominant technology, and the storage layer, Parquet, that's an optimal kind of pairing of technologies, and we've seen that uptake robustly, especially in the Python ecosystem.
Yo creo que conozco como 7 logos apenas.
About is the rise of Arrow native computing systems. And so Dremio, which I partnered with on the creation of the Arrow project from the early days, was built as an Arrow native engine from the ground up. But I see I put Dremio twice on the slides. I apologize for that. But one really exciting project has been NVIDIA's Rapids project, the cuDF library and related.
¿Qué onda, Seba? Saludos.
SQL query engine built on top of Rapids, which is a GPU native, data frame project and analytics framework, and has demonstrated that you can achieve amazingly good performance, not only in wall clock time, but also in power utilization and total cost of ownership. By using Arrow, not only do we get the benefits of this faster data access and faster data movement, but we can also bring down the cost of computing by utilizing hardware innovations and hardware.
Está muy loca esa idea de almacenar data frames en GPUs. Creo que de eso va Rapids. Y bueno, por ahí Apache Arrow es parecido a Apache Arrow y Parquet. No, Apache Arrow es como que más comprensivo. Es todo un set de, a lo que entendí, incluye almacenamiento, y dentro del almacenamiento entrarían herramientas como Avro o Parquet.
We've seen a really vibrant Rust community develop there. And so there's a number of projects which are using data fusion, which is written in Rust, as the basis of their query engines. And so excited to see how that develops there. Also seeing some academic projects like the Noise Page project from CMU adopt Arrow as their cold storage format and as part of their query engine runtime. And so to see Arrow embraced by the academic database community is an important step in the growth of the project, and seeing that both not only robust adoption in industry, but also in the academic world. So a cool project, just to give you an idea of some of what's become possible in 2021. There's a new Python project called Polars, which is named after kind of inspired by Pandas, of course. It's a data frame library similar to Pandas. It is built on the Rust Arrow project and data fusion. So the core of it is all written in Rust. The data processing, the kind of the internals of it, but you can use it from Python. You can extend data.
¿Será hora de aprender Rust? ¿Alguno de ustedes sabe Rust? Qué locura. Por ahí también parece que viene bastante fuerte. Y bueno, estaba viendo comparaciones y que supuestamente es aún más rápido que Go. Bastante interesante.
Looks like. Arrow, we've been, over the last couple of years, been working on creating a, full stack kind of data platform, query execution, data transport, the Arrow Flight framework. Some of you may have seen other talks that I've given where I've talked about Arrow Flight and our use of gRPC and making it easier to add Arrow support to systems so that they can send and receive Arrow data natively at high speeds. And so if you're interested in this work, I encourage you to check out what we're doing in the open source project. The way that we're integrating a lot of this functionality into user language interfaces. So if you're a dplyr user,
He he escuchado bastante hablar de Rust. Nunca le he echado un ojo. En comparación con C, ¿cuán rápido es Rust? Honestamente no sé, pero veo difícil que alguien le gane a C, pero si Rust lo logra es bastante impresionante.
Internally and execute it, as best we can directly on top of Arrow. So very exciting stuff, and we'll be seeing a lot of improvements and new features here over time. So definitely a high level view of the changes that are taking place, but I would say to keep an eye on what's happening here. Encourage your software vendors, if they are not doing things with Arrow already, to look at how they can plug into it, provide an Arrow-based interface, at least for data input.
¿Y solo ensamblador le gana a C? No, sí, C es el rey de reyes todavía, me parece.
A lot more interoperable. So I'm very excited about the future of data analytics systems, and excited. Definitely the last 5 years has been really interesting building this project. The next 5 years are going to be even more interesting, and so a lot of innovation to happen here. So thanks for coming to the talk, and thanks for having me, Tecton, and everyone at the conference.
Wes, do you mind if I ask you a few questions real fast?
Sure.
Nice. Well, I blew through the intro, so we're running a little early, and
Okay.
we get time to talk with you. Thanks for doing
Great.
this, man. Absolute legend. I appreciate it. And there's some cool questions coming through in Slack.
Mm-hmm.
First one is more of a statement, but it's from Dave saying, "Oh, it's interesting. Wes didn't mention Julia when you."
Le preguntan que por qué no mencionó Julia. El lenguaje Julia.
No particular reason. There is a Julia Arrow project. I mean, to be honest, I haven't kept up. I haven't kept up too much with developments in data analytics specifically in Julia, but I'm very excited about what's possible there. I think that the single language, the best of both worlds approach of Julia makes a lot of sense for as a user language, where you can get really fast user-defined functions which are compiled by Julia that can be pushed into a general purpose query engine. So at the moment, it would be relatively straightforward, I understand, to write a custom function that could be inlined or passed into the Rust data fusion query engine. So that's something a proof of concept that I would be interested for somebody to build. So we're working on getting the Julia Arrow project integrated with the Apache community, and I'm interested to see a developer up there. So I think I talked a lot about Rust in the talk, because we've just
Estaba hable y hable de Rust. Dice que hay un montón de nuevos programadores de Rust. Hora de subirse al tren.
really excited. Of course, C++ is not going anywhere, but it's great to see so many people excited about doing data analytics in Rust.
Nada que ver con la plática, pero ese bigote, bueno, me dieron ganas de volverme a dejar crecer así.
Storing data, that will eliminate the constant translation of Parquet to Arrow and vice versa.
It depends on what's meant by storage. I think for longer term or archival storage, Arrow is not designed for the needs of that. So for example, it's not intended to be space efficient on disk. And so if you want your data to compress down to be as small as possible, but then can be read quite quickly, Parquet is a quite good format for that. So you can have a massive data set that ends up being quite small when it's encoded to Parquet format. Whereas Arrow is designed for memory speed performance. So as a data format for caching, as a data format for caching, it's ideal for that, where you can deliver data at memory speed, or if you've got very fast networking, you can deliver data over Aeroflight at more than 10 gigabits a second. There's a new project at Microsoft called Magpie, where they've created an Arrow-based data fabric that uses Aeroflight to cache and access Arrow data and different query engines, and to deliver query results to users. So there's different, I think there's different needs there. But I think replacing Parquet for archival storage, I think there might be scenarios where it would make sense, but in general, the data formats are optimized for different needs, and we found that we can deserialize Parquet files so fast to Arrow format that the overhead there is not contributing that much to slowing down systems at the moment. But we'll see how things change over time. Of course, if disk and cloud performance starts to approach memory speed, then I think
algo de McFly, pero no estoy muy seguro de que eso fue lo que dijo.
when and if that happens.
Yeah, cross that
Estoy
bridge when
buscando.
we come to it.
Y bueno, ahorita habló de la diferencia entre Parquet y Arrow.
Potential ways to reduce language silos. Have you tried OpenAI's GPT-3 for high-level programming language intertranslation for analysis?
I have not. Yeah, I mean, to be honest, it sounds like science fiction to me, but perhaps in the fullness of time, we'll be able to do program, code auto translation from one language, from one language to another. I will say that given the experience of building a project like Pandas, which is very complex and has hundreds or thousands of different APIs, that statically reasoning about the semantics of a particular piece of code can be really challenging. And so to create a machine translation framework for code strikes me as being very difficult. I mean, I think human language is also very difficult, but it's a different kind of challenge where I'd be excited if somebody is able to solve that problem, but it's outside of my wheelhouse.
Yeah, for sure.
Mencionó algo de Apache Fly, pero no sé qué es lo que dijo al final de cuentas. A ver si por ahí lo ponen en el Slack.
That is easy to use, similar to VB6 or C# for Python. I have tried Streamlit and Tinker.
La banda ya anda preguntando cosas genéricas de Python.
Given that I spend most of my time in Emacs, and so I wish I could help more on that question, but
¿De qué trata? Es de Machine Learning y Data Engineering. Y es el que están entrevistando, bueno, el que está ahorita ahí contestando preguntas es el creador de Pandas, súper famosa biblioteca para hacer data analysis.
another question. So there's a few other questions that are jumping up last minute as they do. Does Arrow support common pandas data frame methods?
It is beginning to. So we have a narrow subset of functionality that's implemented. If you use PyArrow, the Python Arrow library, it's a low-level framework, so it's intended for package developers to use. So it provides low-level access to various algorithms, data access, in-memory computing. It's not trying to provide an end user experience similar to the way that Pandas is. So our goal for the Arrow libraries is to be used to build new data frame libraries, or to be used to retrofit libraries like Pandas with Arrow-based computing machinery. So we don't have the desire to craft like the next data frame library, but the low-level computing facilities. We've built a number of them. We intend to build the rest so that we can efficiently compute complex queries natively against Arrow data and have good performance on the current generation of hardware. So we're implementing Intel optimizations for things. We'll need to implement ARM optimizations for things as well. But we'd like to do as much of that work in one place and to have.
Pregunté sobre qué proyecto de Microsoft, a ver si responden, Sebas.
Code for Arrow.
All right, last one. Well, maybe not. You mentioned CPUs and GPUs. What about FPGAs? Thank you very much.
I know that there has been some work using Arrow on FPGAs. I myself have never written VHDL or used an FPGA, but there was a project out of TU Delft, I believe, where they built a project called Fletcher, which provides some glue between Arrow and FPGAs to make it easier to program, to provide like easier programmability
Ahí está la respuesta.
for FPGAs.
Total.
So I think there's FPGAs, and there's a number of companies now that are building AI optimized or data analytics optimized kind of specialty computing chips. You can look them up. I won't name them here, but I think we will see more specialty hardware that can be used within a heterogeneous computing context. So maybe like certain algorithms, like this hardware is really good at aggregating data, like doing group bys, and so we'll push the data to that chip to do group bys and things like that. So I'd be excited about that.
Nice. Okay. So last one for real this time. They just keep popping up, so I guess that's a good thing. What's your perspective on using protobuf as a binary storage format? In my opinion, great for in-flight data using gRPC, but haven't seen much in terms of storing proto on disk.
Well, I know that Google warehouses a lot of data in protobuf format, so it's certainly
It's a MacPy.
Doing that. So one of the cons is that you have to get the .proto file, and you have to compile. You have to run a code generator in order to access the data file. So it does make things more difficult to access the data. There's definitely use cases for protobuf that don't make sense for Arrow, like highly sparse data with thousands or hundreds of fields that are mostly null. So there's still lots of valuable uses for protobuf, even with new formats like Arrow that are designed for analytical query processing.
Nice. So that's all the time we got. There are more questions that are coming in for you, but I'm going to have to direct you to Slack. And
okay.
If anyone else wants to ask you questions, Wes is in the Slack. So Jump in it. Thanks, Wes.
Thank
man.
you.
This was awesome.
Thank you.
This was very cool. Absolute legend right there in the flesh. Pandas. Lots of people thank you for it. I know a few people that don't, but we'll talk about that later. So great. Let's talk about the next.
Tiene otra conferencia. Esa es la que estaba esperando. Es bastante interesante seguir a esta chip. Hasta el momento ha estado entretenida. Creo que después de la conferencia de chip, viene un break. Y creo que tengo que ir a preparar comida. Pero bueno, ahorita igual si me tengo que ir, les paso el enlace, de todos modos. Bueno, de todos modos, la conferencia es esta, applyconf.com. Ya perdí mi lupa, pero está, applyconf. Por si ustedes la quieren seguir ya después. Pero por lo mientras, ¿qué les ha parecido? ¿Han descubierto algo nuevo? Yo no sabía mucho sobre Apache Arrow. Digo, sigo sin saber nada, pero al menos ya tengo una idea en general de qué es lo que hace. Y les recomiendo que, si tienen Twitter, que sigan a Chip. Está como Chip Pro en Twitter. Y bueno, habla sobre Machine Learning en producción. Me entristece ver tantas tecnologías que jamás usaremos en el sector gobierno. Probablemente. Sí, creo que es como las escuelas públicas, ¿no? Como la mayoría de las escuelas, la adopción de nuevas tecnologías es bastante lenta. Pero sí entiendo ese sufrimiento. ¿Qué demonios? Dijeron 1 minuto. Nunca trabajé para el gobierno, pero sí conozco gente que trabaja para el gobierno y sí es lamentable el estado de diversas cosas ahí en el gobierno. Pero ¿qué le va uno a hacer? Hay mucha burocracia. Me pusieron musiquita de fondo, pero no sé si se alcanza a escuchar. Hey, dijeron 1 minuto. Pues sí, se supone que me iba a sentar a jugar videojuegos y resulta que ahí en el trabajo nuevo comentaron sobre esta conferencia y fue así como que, ok, vamos a verla. Se supone que mañana también hay otra, así que probablemente también me conecte a verla. No otra conferencia, sino la misma, pero van a hablar de otras cosas. más o menos a la misma hora por si le quieren caer. Se supone que es a las 11 de la mañana, tiempo del centro de México. Y al menos en la TAM, mucho anda comparando. Pedidos con precios inflados y calidad horrible. Sí, hay mucho corrupción y nepotismo. Estoy de acuerdo con eso. Como que nadie se gana por sus propios méritos. Al menos eso da esa impresión, sin duda. Y bueno, no solo para contratos de tecnologías o del área de tecnologías de la información, sino para casi todo. Bueno, en realidad no entiendo a qué se deberá. Porque si bien hay corrupción en diversos países, me parece que sí, definitivamente los latinoamericanos son los que más se sufre de esto. Y bueno, ahorita en lo que estaba aquí, algo que me sorprende es que si bien hay corrupción, por ejemplo, en Inglaterra, aquí en donde estoy, es como corrupción a los más altos niveles, por ejemplo, lo que hoy se menciona, ¿no? De contratos y demás. Mientras que en Latinoamérica creo que la corrupción permea y llega hasta los más bajos niveles. Por ejemplo, aquí nunca he escuchado, y bueno, a algún nativo que hable de que sobornó a algún policía o de que sobornó en alguna oficina de gobierno. Así digamos que los ciudadanos de a pie, como que no están frecuente eso. Es que en Latinoamérica me parece que es algo de lo más normal. Se ha normalizado un grado tremendo. Topic: yo andaré en el Filsol del rancho electrónico desde el viernes, sábado y domingo. Pondrá bueno. ¿Eres Linuxero, Humberto? ¿O qué otro software libre utilizas? Deberías pasar el link también. Bueno, ahorita lo investigamos. Ahí está, frisol.info. Linuxero no tanto, es por la escuela. Dale. Sí, tengo muy pocos recuerdos de lo que me obligaban a utilizar de sistema operativo en la escuela. No recuerdo que me hayan pedido estrictamente alguno. Aparece música de Minecraft. Ok, comenzamos. Y la calidad del video recayó. No quiero que me pongan copyright por la música. Parece que vamos a empezar unos 10 minutos tarde. Pero bueno, ¿qué más tienen por ahí? Yo les cuento que en el trabajo los viernes todos los viernes tengo oportunidad de hacer algo que se llama Research Day. Y es básicamente un día para estudiar lo que tú quieras. Bastante interesante. Y la verdad es que muy bienvenido. Puntualidad inglesa. No creo que sean ingleses.
Chip coming up. So,
Yes.
Stanford, who will discuss how machine learning is going real time. If you didn't catch it on the slide, that's what we're talking about. So, Chip has helped companies like Snorkel AI, NVIDIA, and Netflix deploy machine learning systems. She's also published 4 best-selling Vietnamese books. Talk about versatility. And now she's going to come on here and talk to us. And like I said before, you probably know who she is. She is quite prolific when it comes to being out there and talking about machine learning and ML ops. I am very excited to have her on. So thanks, Chip.
Hi, my name is Chip. I'm very excited to be here today. Thank you so much for having me. I'm going to be talking about real-time machine learning. A little bit about my background. So I actually come from a very non-technical background. I had published a few non-technical books before I went to college and became an engineer. I have done machine learning at several startups and big companies such as Netflix and NVIDIA. So currently I am working on my own project on real-time machine learning, and I'm also writing a book for O'Reilly. As a motivation for this talk, I just want to mention TikTok. I assume that a lot of you have already heard of it or have an account on it. I never got a hang with, but I heard it's amazing. So TikTok is one of the biggest social phenomenon in the last few years. Like it totally eclipsed what came before it, like Vine or Snapchat. And one objective I kept hearing people say when they mention TikTok is that it is extremely addictive. So and there are many reasons to explain why TikTok is so addictive. And I would say one of the reasons is their technologies. So
Para mis TikTokeros.
has been able to build a really incredible infrastructure that allows them to do online real-time machine learning, to allow them to learn users' preference very quickly. So if you download a TikTok, you can just like spend a few minutes scrolling through a few videos and they can learn exactly what you like, and they recommend to you like what videos you will most likely to watch next, giving you a really great user experience. Happy user really. In my talk today, so I'm going to cover two levels of real-time machine learning. The first is online predictions, and the second is online learning. Before we go ahead, I just want to go over the definitions of real-time. So real-time is this kind of ambiguous term, and I think people might want to argue. Whenever I bring up real-time machine learning, people always ask me, "What do you mean by real-time?" So you talk to philosopher and recently like quantum physicists, they might say something like there's no such thing as time. And if you talk to software engineers, they're going to say something like there's no such thing as real time. Like no matter how fast the systems are doing things, there's always some delay, whether it can be in milliseconds to like even in nanoseconds, but there's a delay. So what real time means is different for different type of systems. So for online predictions, real time is defined to be like in my definitions is defined to be between milliseconds to like 2 seconds. Whereas when you do online learning, real time means like in order of minutes. So also like I just want to go over like what it means to be like a model versus system, because I say system a lot. So model here means machine learning model, whereas systems means the entire system, including the interface, data, compute infrastructure.
Me voy a robar este diagrama.
To the first level is online predictions. If you have built any kind of system for users, it really knows that like latency matters a lot. There have been many research done to highlight the importance of latency. And here's two of my favorite research studies. One is by Google. Google, even back in 2009, they found out if you increase latencies from like 100 to 400 milliseconds, you can reduce searches by like 0.2% to 0.6% per users. And Booking.com is a more recent study, and it says found that if you increase the latency in like by 30%, you can reduce conversion rate by 0.5%. And because conversion rate is directly tied to a revenue, like 0.5% conversion rate means a lot in terms of financial consequences. So no matter how great some machine learning model are, if they take just milliseconds too long, users are going to click on something else. A trend with machine learning in the last few years is that we are embracing the bigger, better approach. So I remember that back then we were talking about like we can build like a model with 1 million parameters, and it was like, whoa, that's crazy. And then we had like a model with 1 billion parameters, and now we are talking about models with 1 trillion of parameters. So we have seen that as models get bigger, their performance, so they will achieve better performance. But a cost of that is that like they tend to take longer to make inference. So so when models like BERT or GPT first came out, a lot of people worried that this model is going to be too slow to be useful. So imagine if you want to predict what is on the time next on the phone, and if the time it takes for the model to predict the next character is longer than the time it takes for users to actually type that character, that model is not going to be very useful. So one way to get around this is that like just don't do online predictions. So it's like when users enter a query, you just don't make prediction based on query right away, but instead you try to generate all the predictions beforehand. So if you don't do online predictions, there can be no prediction latency. So so if you don't do online predictions, what can you do? So one approach is doing batch predictions, is that you generate all the predictions before offline in batch, and you store them somewhere, such as in a SÍGUEME table, and you only pull out pre-computed predictions when needed. So batch predictions have been very successful, and a lot of companies are still using it. For example, Netflix. Netflix is definitely very famous for their recommendation systems. So when you open the Netflix homepage, you will see a lot of recommended movies to you. And these recommendations are not generated as you open the web page. They're actually pre-computed somewhere. And only when you opened the Netflix website that you can see this recommendation, because they're going to be fetched from there somewhere in storage somewhere. So if you try to refresh the Netflix, you will see that even though the order of the rows might change, the actual movie recommendations don't change. So there are like a lot of problems with batch predictions. Yes, they are great, but they have certain drawbacks. One is that you need to know exactly how many predictions you generate beforehand. So it means that you need to have a finite input space. So in the case of Netflix know exactly how many users are there, and you just need to pre-compute on the recommendations for these users. If there's a new users coming, you can just give them some generic recommendations, such as an average or just the most popular movies. So another problem with batch predictions is that they can't adapt to changing interests, right? So for example, you have been using Netflix and you have been watching a lot of horror movies. So the recommendations are going to include a lot of recommendations for horror movie. But then you're feeling very happy today, so you want to watch comedy. So look into comedy category. You want to search for comedy movies. So you would think that Netflix would be able to change the predictions recommendation to show you more comedy movies, but actually Netflix can't, and it can only update the recommendations for you.
Es bastante buena, chip, bro. Por eso que no estoy diciendo tantas cosas, para ponerle atención.
By forcing the input space to be finite. So for example, like TripAdvisors, when you open TripAdvisors, it first make you choose a city, for example, San Francisco or New York, and choose a category like inn, a hotel, or restaurant that can show you good recommendations. But if you try to enter some wide queries, such as high rating Thai restaurants in Hayes Valley, the result you receive is not going to be very good. Online predictions can help you overcome these drawbacks. And also online predictions can allow you to use dynamic features. So what are dynamic features? Static features are features that don't change very often, such as age, gender, neighborhood, job, income. Whereas dynamic features are those you can change very quickly. For example, what am I reading right now? What am I watching right now? Because you can imagine just what am I reading or watching right now is very important to predict what I want to watch or read next. Online predictions, so to be able to do things, to do online predictions, you will need several things. So first, they need fast inference, a model that can make predictions in the order of milliseconds. The second thing you need is a real-time pipeline, a pipeline that can process data, input into model, and return prediction in real time. So the first, for fast inference, there are many ways, but there are three main ways to make it happen. So first is to make models faster. Second is to make models smaller, and the third is to make hardware more powerful. To make models faster, there have been many exciting approaches, and here are two of my favorite solutions I have seen as come across. So to make a model faster, you can do things fast as like you can fuse operation together, or you can like write specific kernels like to do certain kind of operations. You can do dynamic tensor memory. You can so like compile a model to like optimize the executions on certain hardware. So here's my two favorite solutions. Is one is Apache TVM and another is TensorRT. Feel free to check them out. They're really awesome. To make models smaller, also known as model compressions, there are like many different approach. So so the most popular approach is
Creo que sus slides estaban incompletas.
like precision as in precision accuracy, but precision as in as the number of bits that you need to store a number. So usually if you want to store a float is 32 bits. So if you reduce the precision by half, then you need like 16 bits. A lot of companies currently using integer inference, so they really store weight in integer, which really takes up 8 bits. Another approach is knowledge distillations. Is also known as like student diction network. So you have a big model that does something really well, and then you want to train a smaller model to mimic the behavior of this big model. Also, pruning is when you try to like set on the weight weight or activation to that's not very useful to 0. And so lowering factorization, like you have a very large matrix, you want to reduce the demand, so you want to factorize this very large matrix into like lower ranked matrices. I think it's just really interesting, and when I just look into like what kind of model compression solutions are there, and I just found like 42 model compression open source projects. I think there have been more have been coming out since then.
El hola mundo de modelos, el mundo de Machine Learning es el dataset del Titanic o el dataset de precios de casas. Tal vez le tengamos que echar un ojo después.
They were able to improve their latency by like 30 times. Another approach to make fast inference is just to make hardware more powerful, so you can do inference on this hardware faster. And there have been many different hardware startups focusing on like both training and inference on both like cloud and on device hardware.
Ok, bueno, sí. Si quieres algo básico es perceptrón. Aprende que es un perceptrón. Pero eso es como más... Sí.
Allow for online predictions is a real-time pipeline. And just to highlight what a real-time pipeline is, I'm going to use a ride-sharing example. So imagine you're trying to predict whether a transaction is fraught with a ride-sharing system such as Uber. You might need features from various aspects, such as like you want to know about the specific transactions. You want to know about users' recent transactions, for example, over the last 7 days. You want to know about this credit card recent transactions. For example, like if this credit card had been added was added only 2 days ago, I have seen like 20 different transactions, and maybe it's a red flag. You also like want to like use like look at the recent in-app frauds, because maybe it's a bit a new way of like committing fraud, and maybe this is related to that somehow. So you want to use a lot of recent features. And the question here is that how do we quickly access these features? Because you don't want to put those features in some permanent storage like S3, because like each time you need to pull out these features is too slow, and you want to detect the fraud as soon as possible. So one way to do it is just to store all those recent features into memory. So every time something happens, like every time users does something in app, for example, like fix the locations, book a trip, you can like add a credit card, or contact driver, or cancel a trip. You want to store all of them into memory. So for honest event, after like 7 days, or you can set like 7 days or 10 days, it's up to you. Once these events are no longer useful, you can either discard them or move them to permanent storage or S3. And this is exactly what a stream storage is. So the most popular solutions is probably Apache Kafka, and Amazon also has a very popular solutions. It's called Amazon Kinesis. And if you go on StackShare, you can see like hundreds of companies are using these solutions.
En el trabajo usamos Kafka, al parecer.
Do online predictions, you need not just static features, so you need both static features and dynamic features. So static features come from like static data, so you can have data in something like CSV or Packet. Packet is a really exciting data format that I always recommend companies I work with to use. So for static data, it's usually bounded, so you know when a job finishes. But with streaming data, you just like don't know when it finished. It might never finish. So for static data, you can process them in batch, so using something like SQL or MapReduce. Whereas like for stream data, you want to process them as soon as they arrive. So you want to use tools such as like Apache Flink or Samza. So you can a lot of people like both in academia and in the industry, when you train a model, you usually use train model using static data. So whereas when you do inference, you usually do inference on streaming data. So you can see that like there are already two pipelines. So you have one machine learning model, but like two pipelines. So for training, you have static data, you go batch processing and you extract features and you input into the model. And in doing inference, you have streaming data, you go through stream processing, you extract features and you input the feature into machine learning model. So it's actually a very common source of errors in productions, and it is especially common when these two different pipelines are maintained by different teams. So imagine, for example, the training pipeline is maintained by the machine learning team, whereas the inference pipeline is maintained by the DevOps team. It seems like it might seem like an overfetching example, but actually pretty common. So here's an example of Weibo. So before they actually have two completely different pipeline for training and inference, they call it offline pipeline and online pipeline. So Weibo actually spent a lot of effort into unifying this pipeline using Apache Flink. So you can see like on the top is a previous pipeline, and now they have like unified pipeline. And it's not just Weibo. We have seen that
Está hablando de Weibo, una red social china.
Lyft. So if you want to talk about like stream processing, you kind of want to talk about microservices as well. So you must have heard about microservices. It has taken the world by storm the last decade, and going hand in hand with microservices, usually REST API. If REST API like doesn't mean anything to you, don't worry, yet we're gonna go over it very quickly. So for REST API, usually REST API is request driven. So what it means is that you have a client and a server, and the client sent a request via something like POST-GET to the server, and server is going to return a response. So server has to listen for the request to register. So if for some reason the server is down, then the client will have to keep on pinging the server until it gets a response back, or it can have something timeout when it doesn't work anymore. So it can get like really complicated. So imagine you have a ride-sharing service again, and you have like three different services. One is rider management, and another is driver management and price optimizations. So rider management need to ping the driver management to get like understand driver availability, and paying the price optimization to get the price to show riders. And so the driver management needs to ping the rider management and price optimization so that they can tell like how many drivers they should mobilize, or what surcharge they can give drivers so they can encourage them to get on the street if they're like an overwhelming demand for rides right now. And similar with price optimizations, we tend to link both rider and driver to get information. So inter-service communication can get really complicated and can make it very slow with data transferring back and forth. So another problem with like this request driven is that because like each microservice manages their own thing, it's just no way you can, or it's it's going to be very difficult to map the data transformation through the entire system to get a good pictures of like what's going on, or like it's going to be very hard to debug. Like if something is down with price optimization, you need to go back into rider management and driver management to get a good picture of what happened and what causes. So instead of doing this like request-driven model, what if instead of like different services, microservices pinging each other, what if we have like on the microservices to like publish something to a stream, and whoever wants information from that service can just like subscribe to the stream and get a.
¿Han escuchado hablar de este modelo? PubSub.
Now everyone might publish and subscribe to a same stream and gets and publish information they want and just get information they want from the stream. So because now we have like data flow through this stream, so you can actually build a dashboard to monitor data transformation through the entire system. And this model is called PubSub, short for publish and subscribe. But there are also other systems for event-driven approach as well. A lot of companies have been doing stream processing, but also a lot of companies are not doing stream processing. And there are like a lot of reasons. One reason is that companies don't see the benefits of streaming. So maybe it's our system. The system is not as a scale where inter-service communications is a problem. And so you don't have to switch to the event-driven model. Or like the best predictions have been working just fine. And also because you have never done online predictions before, so maybe online predictions can help give you improvement, but because you've never done it before, you don't know that they will, and therefore you're not motivated to like change your infrastructure to do that. Also, like to switch from like batch processing to stream processing can require high initial investment on infrastructure, which a lot of companies are not willing to do, especially when they can't see the added benefits yet. You also like require mentorship from doing batch processing to stream processing. So like if you used to do things like in static data, it's very hard to like work with data that will never terminate. And also like a lot of tools in streaming processing right now is Java based, and a lot of people working with machine learning is like very comfortable with Python. So you need to switch to using stream processing. You will need to like work with tools that you're not familiar with, and of course there are tools that like let you handle things in Python, but it can be like pretty awkward to use. And for the next part, is next level of real-time machine learning is online learning. So something I'm really excited about. So to begin, like online learning is different from online training. So online training is you can learn from each incoming data point, and it has a lot of it's very difficult to do because it can suffer from catastrophic forgetting. I talked to several companies, they have tried doing it and none of it ever worked. And it can get very, very expensive because like imagine you have some hardware that is capable of doing computations on like a lot of samples at the same time. So if you use that hardware to make the computation on only one sample, that can get very, very expensive and wasteful. So the companies that have seen that doing online learning successful in practice, they learn in micro batches. So instead of learning
No sabía que
every
había
incoming
diferencia
sample,
entre online learning y online training.
they learn with every coming like 500 or 1,000 of
Python
samples.
es una buena herramienta para tener en tu...
With online learning, one challenge it was evaluations, right? So the first step you want to do offline evaluations, so that you want to evaluate some models on some static data to make sure that it's not doing something crazy and like ruin everything. But the point of online learning is that you can adapt the model into changing interest, changing environment. So it doesn't make sense to test the model on something that is non-changing invariable. So the only way for you to really test the model is to like farm it out to different users and see how they behave. So the popular system is A/B testing, and it's just so A/B testing here is make it sound very simple, as you just need to compare like system A and system B, whereas you actually have to compare like many different versions of your system. So actually it's just totally a startup idea. You can build a system to have companies do complex A/B testings with online learning. Many companies say also online learning that doesn't mean that you don't do offline learning. Many companies do online learning in tandem with offline learning so that it can produce a more stable system. So in traditional offline learning, the iteration cycle can take up to like months. Some companies can be really fast and in weeks. But when you do online learning, Weibo is for companies like Weibo, you can do it in 10 minutes iterations. So you can like extract new features, you can train models, and you can
10 minutos para entrenar un modelo en línea.
There's different use cases for online learning, and the most popular use case right now is for recommendation systems. So the reason is that like recommendation systems problems have natural labels. So if you give users a lot of recommendations, you can just observe how users react to these recommendations and get the label from it. So like if user click on a recommendations, you know that it's a good prediction. If they don't click on it, they will look on it, it's probably not a good recommendations. I also just want to clarify that not all recommendation systems need online learning, because there are many systems that many systems that have very slow to change references. For example, users' preference for houses, cars, flights, hotels are unlikely to change very quickly. Whereas users' preference for things like online content, such as videos, article, tweets, memes, they can change very quickly from second to seconds. And for this kind of systems that have quick to change preferences, you want to learn user preferences very quickly. So online learning is going to be very important for this kind of system. There are other use cases for online learning. So one use case is for rare events. So imagine you have some events that rarely occur, such as Black Friday for shopping. So Black Friday happens only once a year. It's really impossible for you to get enough historical data to predict what users are gonna do this year. To be really effective, you want to learn on the fly on that day, on Black Friday, just from the beginning, to see what users gonna behave, what users gonna do next. Also, it can help you avoid the cold start problem. So imagine you ship an app to users because it is a new user. You don't have any data on that user to predict what they like. So if you don't do online learning and you do offline learning, then you have to wait until the next time models is trained and deployed, so that you can produce relevant recommendations for that user. But if you do online learning, then you can just wait for users to spend a few minutes on the app, and you can get users to can show users very relevant predictions like TikTok does.
Yo diría que Python te deja hacer lo que te da la gana. Tal vez la velocidad no sea lo ideal, pero Python te deja hacer muchas cosas. A menos de que estés trabajando con cosas muy extrañas.
Of machine learning is to train a model with sufficient number of epochs until conversions and evaluate on a static test set, right? In online learning, there's no such thing as epoch, because you see each data point at most once. There's no conversions because the data is constantly shifting. You have no idea what the model should be converging to. And also there's no static test sets. You have to do online testing, A/B testing.
Ok, sí, memoria, tal vez.
So
Sí, sí,
actually,
sí.
when I was looking into
Python es muy bueno.
machine learning, I actually very surprised because a lot of great examples I found actually from China, and I haven't heard of this before. So I posted thing on link on social media. I know social media is not legitimate evidence, but I think I started some really interesting observation from people who have been working with both Chinese and American company, and they have and they some of them has told me that they have observed the same thing as well. So if you have seen something similar, I would love to hear. So when we talk about the AI race between US and China, a lot of people have been citing things like the number of papers, the citations, but also there's another very interesting metric is the adoption rate. So if you look at firms that are adopting AI and firms that are piloting AI, you can see that actually the number is a lot higher in China than in the US. So it seems like there's the AI adoption in China is more mature, and maybe maybe that's why they can build better infrastructure. There's also other reasons. So somebody told me that I know a lot of this is very hungry. There's no scientific research behind it. It's a lot of this is anecdotal evidence. So please take it with a grain of salt. I would love to hear your feedback as well. So somebody told me that it looks like a lot of internet companies in the US are old. And yes, they're decades ahead of Chinese companies. And one thing that come with that is that they have more legacy infrastructure. So every time they want to change the way they do things, they need to update the infrastructure. Is very expensive. Whereas in Chinese companies, they can just build things from scratch, and it makes it easier for them to adopt a new way of doing things. And so it seems like there's a more national effort from China than in China than in the US. So I'm actually working on something related to machine learning. So if you want to discuss more about it, please feel free to reach out. Thank you very much.
Ahí está. Muchachos, muchachas, súbanse al tren del MLOps. Invito. Invito al tren.
get to chat for a little bit. You all can hit the bio break if you need to. I'll be here explaining a few things, and I get to do my favorite thing ever, which is give away a little swag. So if
Un pipeline así de C++, Fortran, de trabajo basado en hacer el mejor esfuerzo y obtener el mejor.
person who put a funny selfie in already, which is Deepan Shu Sani. For that selfie that you put in, you get some swag. And you're probably wondering, like, what swag am I going to get? We've got a lot of cool partner swag. All of the partners have been really kind and they donated a bunch of stuff. So let me share my screen real fast and I will.
Están regalando cosas y ya también quiero ganar algunas cosas. Ah, olvídenlo. Olvídenlo. Pensé que iban a dar algo más interesante. De hecho, ni siquiera sé si hagan envíos internacionales. Ok, tal vez la playera está bien. Eso me interesa. Es hora de tomar una selfie. ¿Creen que me pueda tomar una selfie así? Súper divertida.
Or put it in.
Pero bueno, yo creo que me retiro, muchachos. Recuerden que mañana nos vemos aquí a la misma hora para ver la segunda parte. Les recomiendo que sigan viendo la conferencia. Recuerden. Aquí está, applycon.com. Exacto, muchachos, muchachas y no binarios. Somos incluyentes en este stream. Cero discriminación. Todos y todas y todes, estamos bienvenidos acá. Pero bueno, los invito a que sigan viendo la conferencia y mañana voy a andar por acá de nuevo comentando. Espero que haya un poco más de pláticas. Pero sí, recuerden, síganme en Twitter, @exception. Síganme en Twitch. That's a sharp guy. Y sigan el otro canal de IRL porque ahí voy a subir estos videos. No creo dejarlos en este canal. No sé qué tanta si les vayan a gustar. Pero bueno, si les gusta ya saben, denle un me gusta. Y pues nada, cuídense mucho, ¿va? Así que cuídense, ¿va? ¿Sí me escuchan? ¿Sí me escuchan? Ok, va. Saludos para todos, para Guinea Ecuatorial, para todos lados. Y muchas gracias a la banda que anduvo por acá. Acuérdense que mañana misma hora. Es la de campos, así es, así es. Y por ahí que Humberto Cortés preguntaba que si así andaba en el trabajo, sí. Estaba con la gorra, con el short también, en el trabajo. Pero va. Ahí nos vemos ahora sí. Cuídense mucho, por favor. Tomen agua. Disfruten de su viernes si es que están trabajando. Y no, ya saben, sigan viendo la conferencia, ¿va? Nos vemos, cuídense mucho.